Hi everyone, this is Pradeep. Good morning, good afternoon, good evening. So we'll get started now. So before we get started, as usual, we'll have a general question answer session. So if anybody wants to ask anything about yesterday's session, if you have any questions regarding yesterday's session, you can ask now. We can just wait for everybody else to join in, and in the meantime we can just have answer those questions if you have.
Okay.
Okay. Susan, do you have any questions?
I got it. Thank you.
And I guess we have Shanti with us. Probably that's the name, if I remember correctly.
No, I don't have any questions.
Right. Okay, so in that case, we will resume our introduction to Java. We were yesterday discussing about the distributed and nature of Java, how Java is distributed or how it supports distributed computing. And apart from being like distributed in terms of computation, Java also gives you the ability to work in teams. So what does that mean? Basically, working in teams means that there are different people working on different parts of the project, and you can do that easily with Java because most of the source code can be organized in modules, uh, and you can break down a project into modules and libraries that can then be individually developed by different developers or by different teams. So, for example, if you are building a very large e-commerce system, what can happen is basically the business logic can be written by one team, and in that business logic module or component, you can have people who are working on different parts or different objects or classes of that particular system. So remember we discussed about object-oriented programming yesterday. So everything is an object, or like everything is a first modeled as a class, as a type, and different people can define or create different kind of types when working in teams, so that like you can distribute the entire application logic generation across multiple teams and ultimately across multiple developers or programmers. So Java enables you to do that because of like being able to link multiple modules together to finally create or compile the final project or the final output software that you want to create. Uh, so we also discussed about being compiled and interpreted. So initially, when you compile a Java program, it gets compiled into the bytecode, the Java bytecode, which is a platform independent representation of the source or the software that you write. And then the Java virtual machine and the Java execution environment, or the JRE, which is Java runtime engine, it reads that bytecode line by line or step by step and interprets it, and it converts it into the native platform specific code. So um, just to give you an idea about this a little bit more, what happens is that when we have a computing platform, so for example, you have a computing platform which is, let's say, Microsoft Windows. So Microsoft Windows works on both Intel 86, which is x86, which is known as 32-bit processors, and it also works on 60-bit, 64-bit processors, which is x64. Now, these processors or these hardware devices have got very different memory addressing and data access and those kind of schemes, which are very different. So your normal computer device that you see, which is a 32-bit, will have a different kind of memory addressing scheme and the different way to access data and maybe different data bus as well as compared to a device which is 64-bit computer. Hello, Sonia. Can you please turn off your microphone? We are getting some noise from your side. Hello, Sonia. Can you hear me?
Not that well.
Okay. So I
I
was
think the
saying
audio
that
is really soft and.
okay. I was saying that
Oh
if you
wait,
can
no,
just
I can hear you now. I just wasn't connected to my speakers. That's all.
great, great. So can you please put your microphone on mute because we are getting the noise of TV. Probably there's TV playing back in the background.
Hello.
Yeah. Well, we're still able to hear it, Sonia. Yeah. Now it's better. Now it's better. Thank you so much.
Hello.
Hello, Sonia. Can you hear us?
Can you hear me?
Yes, we can hear you, Siddiqui.
Hey, hi, how are you?
We are good. How are you, Siddiqui?
I'm good, thank you.
Sonia, can you hear us, please? Hello. Hello, Sonia. Can you hear
Hello?
me? Yeah. Basically, can you please turn off your sound because we are getting a lot of background noise from your side.
Can you just mute yourself, Sonia, on the screen? You can hear me, right?
Anyways, so probably she disconnected. So we'll continue with what we are doing. Uh, I hope she has. Probably she has some problem with her microphone or computer device. But anyways, so let's continue with what we were doing earlier. So we have Daniel who has joined us. We have Siddiqui and we have Sonia. So I welcome you all. And we were just discussing about the sessions that we had yesterday. And I just like if you guys have any questions, you can ask me now or after the session. But we'll just continue from the point where we were left off yesterday. Sorry. So I was explaining about the compiled and interpreted nature. So basically, as I said, the Java source code first gets compiled into Sonia. Hello. Hello, Sonia. Can you hear me? Please, can you just turn off your microphone because it's creating a little bit of distraction. Hello. Let's see what I can do here from here. Okay, so we'll continue from here onwards, and if we'll have more distraction, probably I'll ask someone to give her a call. It looks like she has not connected her speakers, so she cannot hear us, but her microphone sound is coming anyways. So yeah, now it's gone. Alrighty, so let's resume what we were discussing. So I was explaining basically the compiled and interpreted nature of Java. So the source code that we write, the programs that we write first get compiled into the bytecode, and then there is a Java runtime environment or Java runtime engine which takes up that source code, reads it line by line, and interprets it to convert it into the machine specific code or machine level specific code. As I was explaining about the different kind of processor architectures, so we have got, if you are like using an Intel processors are like the most widely used processors these days. And so there are two kind of processors on Intel as well. One is a 32-bit processor, the other one is a 64-bit processor. And both these processors have got a different memory addressing scheme, a different way to pass data, and a different way to, or different limitations and as to how much data they can read at one time. So due to these kind of differences, what happens is each platform has got its own specific schema or like format of instructions that it can understand. And that's term, like to, if just to give you a cue about it, you can read more about ISA, which is known as instruction set architecture. So those instruction set architecture specifications help a processor come up with a execution plan for your programs. So when you execute a Java program which has been compiled into bytecode, the runtime engine will take that source code or the class file and then execute it one line at a time. And in doing so, what it does is it also compiles it into the machine specific code and keeps a cached copy of it so that it doesn't have to do the same work again. So if you run the same function again, the same next time it would be already cached in the memory, so it can run it faster. But in the first instance, when it runs, it interprets it and that gets it then gets compiled into the platform specific code. So that's the whole underlying mechanism of how Java execution happens in real time. Obviously, to be a Java programmer, you aren't required to go to that level, but sometimes in more like some advanced scenarios, you are supposed to know these intricacies so that if there is something wrong or if your code is not behaving the way it should, you can just go ahead and take a look and figure out what's wrong, and then maybe it's something that's happening on the code conversion level from bytecode to your actual native source code. Okay, so some of the next features are like robust. So being robust means that you can rely on something and it's powerful and it's efficient. So that's what being robust generally means when it comes to computer science or computer programming. So the first point that we need to be mindful about is that we were discussing about C, C++ yesterday. Uh, C, C++ are very powerful languages. So is Java and like a lot of other languages. But one of the unique features of Java is that it when you write something, there is very little ambiguity. There is like it's very clearly defined as to what you can do and how you can do it. So like you have a total control over the reliability of the program. Moreover, what you can do is basically you can even test your software using various testing frameworks that are available for Java. So what that means is the code that you write can be tested by another piece of code or another code that you can write, which are known as unit tests, basically to test a small part of unit or small unit of your source code, and then you can make sure that it will run reliably on the resulting system. The second most beautiful feature of Java is that there is very strict type checking. So Java is a strongly typed language. What it means is that when we'll discuss more about types and other things when we'll talk about the object-oriented programming. But to start with, just to give you an idea, like we were discussing yesterday about the object-oriented programming, wherein we said that like when you start creating an object-oriented program, you create types. So in Java, you cannot replace one type with another type except for some exceptions, and those exceptions are like inheritance and polymorphism and those kind of things, which are like uh, some of the features of object-oriented programming itself. But you cannot replace a banana with an apple if a banana is expected. So that's what the crux of this thing is. So if you expect me to give you a banana, then I cannot give you an apple. However, if you expect me to give you a fruit, then I can give you either apple or banana. So that's the kind of rules that are here, and I'll explain more about object-oriented programming later on. But just to make the idea a little bit clear, this is the whole crux of being robust. The third part is like there is a feature in Java which is known as garbage collection, or it's memory management. So basically, when you run a program, you use memory to store data in the memory, right? So when you create program, you use up some memory to store some data during the execution of your program. Now there is another feature in Java which gives you or which relieves you of the responsibility of managing that memory yourself. The Java runtime engine will keep a track of what is being used and what's not being used, and something that's not being used will be freed up from the memory so that other programs or other systems can use that memory, so that it can efficiently utilize the resources that are available on your system. Another
Hey, Pradeep.
hello, yeah.
This is Daniel. I joined a little bit later. Are you sharing your screen?
Oh, I'm sorry. I'm sorry, guys. I just missed that. Maybe we were so distracted by this noise coming in that I forgot to share my screen. But anyways, thank you so much for reminding, Daniel. But anyways,
No problem.
Yeah, probably.
All right, thank you.
Thank you so much. I hope everybody can see it, right?
Yeah, I can see that.
Great. All right, so we're talking about the robustness of Java, and the final feature that I would like to talk briefly about is like the exceptions or the exception handling. So as I explained yesterday, exceptions are nothing but like errors that happen when you run a program, and there are multiple kind of exceptions. We'll discuss exceptions in great details in the subsequent chapters. But you have got some very good exception handling features in Java, which help you in making sure that you can cover every use case and scenario that's there, and like if your program is in a positive flow, it's running good, it's fine. You can deliver the functionality that the user expects. But if let's say something goes wrong, and it does go wrong a lot of times during the execution of the program, so there is an error. You are maybe just talking to a third-party service from your program, and you are not able to get a response from there. So that results in a runtime exception, and those kind of exceptions are like the errors that stop your program from fulfilling its functionality. So Java has got a strong mechanism. It's very strong when it comes to giving you the control over the exceptions, and it also even goes as to what kind of branches or paths that you can take in terms of like when there are different kind of exceptions. So a file not found exception can be treated differently than a network input output exception and those kind of things. So that's the idea of how Java is robust. Java is secure because all the first and foremost principle of Java execution is that all your programs, they run in a sandboxed environment. So all Java programs run in an isolated sandboxed environment. What that means is that it cannot access anything and everything on your computer system. So let's say if you are running a Java program on your computer, you can be 100% sure that it will be running in an isolated environment wherein it cannot access all the resources available on your machine. So for example, let's say you run a Java program, and you can be 100% sure that it will not be able to get the cookies from your browser and those kind of things until you allow it to. So you can configure the security policy for running the Java programs. You can define which programs are trusted, which programs are not, and so on. And another part of Java is that it is like your networking, or all the network connections that a program makes are going through a Java execution firewall, which means that by default every program is configured to not allow to be like opening a connection from your machine. Now opening a connection, like if you have a program which is like allowed to make a remote connection, maybe they can steal your information and send it across to another system or another API, which is not a very good thing. So basically, by default, every Java program is allowed to or not allowed to make socket connections. Socket are like the low-level stuff, which is like when you are making two computers talk to each other, they talk through sockets. So sockets are like network connections which happen between two different machines. So by default, like no program is allowed to open up a socket, but you can add exceptions. You can run it in high privileged mode and so on. So that's some sort of security that's built into Java by default. Obviously, you can always override these behaviors. We have been discussing this a long time, and I would just like to give you a little bit of refreshing or refresher kind of a overview of the other features. Like it's architecture neutral, which means that the same Java program, the same jar file can run on a Mac, on a PC, on a Linux machine. So it's like you don't need to compile it again and again. It will be just the same jar file. Just take it and you can run it on a Linux machine or on a Windows machine or on a Mac, and it runs just the same. So that's what it means to be architecture neutral. It's portable. Portable is an extension of being architecture neutral, which means that when you take when you have the ability to take a piece of software and port it or take it to another computer system, which is different in terms of architecture, the execution model, and the instruction sets, it should still run. That's the definition of a portable, portable program. So if you create Java programs, they are by default portable because they run on top of a virtual machine. So if you have the virtual machine available for that particular platform, that program can run on that platform. So that's the idea of Java programs being portable. The other part is high performance. now there are multiple reasons of Java being good in performance. Uh, One of those reasons is that it's a compiled language, so anything which is compiled is always going to be higher in terms of performance compared to something which is interpreted. Why do you get a high performance when it's a compiled code? Because the compilation process is like getting rid of all the strings and building a kind of index and symbols which the program can, like, it's kind of a process wherein you build trees and graphs for the traversal of instructions. So when you start a program, it knows, like, okay, these are step by step instructions, those instructions are codified into memory addresses and everything else, and then on every decision it knows like which memory address it needs to go. So like that information is already sorry, that information is already compiled before the program execution starts. So that's the benefit of having a compiled program against an interpreted program. Now we discussed that Java is also an interpreted language, which means that after it gets converted into bytecode, it gets interpreted line by line. But that also doesn't makes it performance it less performant, because what happens is, like, as soon as it encounters a bytecode instruction, it compiles it into the native source code, and then keeps a copy of that compiled source code in cache, so that next time if that particular code is executed again, it will not be required to be compiled. So that's another benefit. So you get this great platform neutrality and portability and the performance as a result of this mechanism. Java, we discussed about multi-threading. I'll just elaborate a little bit about multi-threading today, but like we'll discuss in great detail. As you can see in the course structure, we have got a specific chapter dedicated to multi-threading. But multi-threading is like ability of a program to be able to do multiple actions at a time. Now, this statement can be misleading. I'll like to warn you right from the beginning that it could be misleading. Okay, what does it mean that a program can, or a software or a program can do multiple things at a time? Now, in reality, this all depends on the hardware that you're using. So, for example, if you have a processor which has got multiple cores, for example, if you have got a dual core processor, it has got two cores on that processor, and it can literally do two things at a time. But if you have got a single core processor, which is like one core processor, it cannot do two things at a time, because let's say if I have got two hands, I can, like, if I train my mind, I can write from both hands. But if I have only one hand, obviously I can write only one letter at a time using one hand, right? So that's the same kind of principle that applies here. So if you have got a dual core processor, a multi-threaded program will run multiple things or two things in parallel. If you have got a quad core processor, it will have the ability to run four things in parallel, and so on. So threads are nothing but like slices of processor time that your operating system allocates to a specific piece of code. So when you create a thread, what it means is that there is some sort of time allocation happening on the processor time from the operating system. That's what the definition of a thread is. Now, if it's a single core processor, obviously that the time slice that the operating system assigns would be on the single processor. So it will be like, you'll have this illusion that because the time slicing happens so fast, you'll have this illusion as if the computer is doing multiple things. But in reality, at any given point in time, if you look on the X series, it will be only one thing that will be happening. If you have got multiple processors, and then the operating system will be able to allocate two threads to different processors, because threads are nothing but the time slice that is allocated to a particular piece of code. So it can run two functions or two parts of code together or in parallel. So that's what multi-threading is in code. Now it gives the Java as a programming language and a runtime environment gives you both these abilities, like you can write multi-threaded programs, you can synchronize between multi-threaded programs. So what happens is, like when you start multi-threading, you also need to synchronize information between things, because if I am doing something, if there is one person doing some job, then that one person doesn't need to communicate with anybody else. But if there are two people who are doing like a job, and one of them does the half and the other one does the half, so they need to synchronize between themselves. Okay, how much has the person A done, like how much will the work will be done by person A, and how much will be done by person B, so that person B doesn't end up doing what person A has already done, or person A doesn't end up doing what the person B has done. So that's the kind of synchronization that is required. And Java offers you those synchronization tools to make sure that you know the threads that run don't interfere with each other, A, they don't corrupt each other's state, B, and they don't end up into race conditions. Race conditions are another area which we need to be careful about, because what happens if you run into race conditions, you might end up deadlocking. So a deadlock is a situation wherein like two threads are working together. Just to give you an idea, like at the minimum you have got two threads which are working together, and thread A is waiting for someone or something to be finished by thread B, whereas thread B is also waiting for something to be done by thread A. And as a result of this, you end up in a situation where neither of them can proceed and the entire system freezes. So that's the kind of idea of having a deadlock. So Java offers you some tools that can help you in avoiding those kind of conditions, race conditions, and ultimately the deadlocks. As we discussed briefly about the linking part, Java is also capable of linking in a new class, in new class libraries and methods and objects. So when you write a Java program and when you create multiple classes, what the linking process does is it links all the related objects together and then generates the final source code. So basically, when you have got multiple modules, what will happen is like the linking process will link all the modules together to generate the final Java file, or the Java archive file that is used as the executable by the Java runtime environment. Java also can link into the native methods that are created in the native libraries. Like if you have a C++ library, code library that you want to use in a Java code, you can do that because Java compiler can link into those libraries. So that's another benefit of using Java. What is Java virtual machine and Java runtime environment? So just to give you a high level understanding of Java virtual machine. Java virtual machine, if you remove Java, it's a virtual machine. So it's a virtual machine. What virtual machine means is that it's a virtual computer system, a full-fledged computer system. So you can think of it as a virtual computer system which has a processor, memory, and a storage device like maybe disk and something like that. These are the basic fundamental building blocks of a computer system. So a virtual machine, a Java virtual machine, is nothing but another virtual machine which has these three components. So it has a processor. It's a virtual processor basically. So what it means is that it has got its own set of instructions, and then it has got some memory allocated to it by the operating system, and it can access the storage. Now that storage could be virtual storage or could be the actual storage on your machine. And as a result of these, all your Java programs run in this virtual machine rather than running on the actual hardware. Ultimately, they end up running on the actual hardware computer system or computer platform on which your virtual machine is running. But from your programmer's perspective, that's the environment where your program runs. Right. The second thing to be aware of about Java virtual machine is that it's platform specific. So the Java virtual machine for Windows is going to be different from the Java virtual machine for a Mac. The same way Java virtual machine for a Mac is going to be different from a Java virtual machine for a Linux. So Java virtual machine is written specifically for a specific hardware, but it's not you who's required to write that, because that's part of the Java software itself. So the company which is now maintaining Java, which is Oracle, is like supplying you with the Java language compiler, the Java runtime environment, and the Java, what do you call it, virtual machine. So these three things are provided to you as a developer. So you can download multiple, or you can download the specific virtual machine that you need for your specific environment. Java programs are compiled by Java compiler into bytecode, and Java virtual machine interprets this bytecode and executes the Java program. So we have already discussed this a lot of times. There is one key part that we need to be aware of about this entire process, is that if you don't want to create software, or if you don't want to write software, you can just run a Java program using the JRE. So JRE is a combination of your runtime execution environment, or the classes which are required for running, and your virtual machine. But if you want to create software using Java, then you need an additional piece of software which is known as JDK. Now JDK comes along with not just the Java runtime environment and the virtual machine, but also with the Java compiler and the Java framework library. So the Java compiler is the piece of software which reads your Java code, the Java code that you write, and converts it into the bytecode. Another part of the Java is the Java framework library. So Java framework library is a set of like classes, or like software or Java libraries which pre-package some pre-defined functionality already for you. For example, working with files. So if you want to read and write files, you don't have to write that low-level code to go to the disk and like read 1 byte at a time or 1 bit at a time, and then do that, transfer into memory and that kind of stuff. That is already taken care of by the Java framework library. So you just have a file reader and writer classes in Java framework library that you can use to just give it a file name, and it will automatically get the file contents. So what you as a programmer will get is the string contents of that particular file. So that is the role of Java framework library. It has got some predefined or like prepackaged functionality available for you right out of the box as a developer, so that you don't have to write or focus on writing that low level code. What you can focus on is like the application logic or the logic of your program. So that's the distinctions, or that's all about the Java environment that we are going to use when creating Java programs. Here are some of the prerequisite tools that I would recommend, and some of them are like absolutely required, some of them are like good to have. So we'll discuss one by one. As I've been saying again and again, you can write and run Java software on multiple or like any platform. So you can have a PC. If you have a PC, that's really great. If you don't, you can also run it on a Mac, which is like a Mac machine. Or if you have a desktop with a Linux installation, that will also work just fine. So any of these environments or any of these machines is going to be okay. So if you want to create software using Windows, that's fine. You can use Java for doing that. If you want to run it on Linux or Mac, you can also do that. There are like certain tools which are required for you to be able to more efficiently write software. It's not that like you cannot. If you ask me, if you have any text editor, like any text editor where you can write text and save it as a file, that just works. You don't need to have any IDE, but that's for people who are like quite advanced. But for beginners, it's really, and for people who have to write, like who have to be really productive in writing software, it's really recommended that you have a tool called IDE. What IDE means is that it's Integrated Development Environment. So IDE helps you or provides you a lot of tools that can help you in writing faster So when you write code, it will help you in writing code faster. B, it can help you in organizing code better. And C, it can also, make you refactor your code easily. So refactoring means that improving the quality of your code. It could be the performance quality, or it could be just the organization quality. So how do you organize and lay out your structures? The third piece is Java Development Kit, which we discussed in the previous slide, which is like the full-fledged runtime environment, including the virtual machine, the Java compiler, and the Java framework library. So this is the complete Java Development Kit that you will need to be able to run first, to be able to write, and then to be able to run those software programs on your development machine. As you can see, there is a link, and it's like pretty straightforward. When you download this JDK, you just go to this link, download the executable program. I can show you here if you want. Yeah. So if you see here, so if you're I would say like this, you can download any of them, but these first two, and this you can download any of them depending on your platform. So if you are on Mac, you can select this one, right? If you are on a Windows, you can select this one. Depending on, like, x86 means that you have a 32-bit processor, x64-bit means you have a 64-bit processor. So depending on your processor architecture, you can select any of them. And if you have a Linux machine, you can download this one. So you have got Linux x86 and x64. You see them twice, because that's because of the fact that Linux comes in two distributions. One is a Fedora distribution, which is like Red Hat and that kind of, and the other one is a Debian distribution, which is your Ubuntu and maybe Lubuntu and other Linux distributions. So you can choose from any of these distributions and download the JDK. And as soon as you download this, like, it's not very straightforward on what do you call it, Linux, but on Windows and on Mac it's pretty straightforward. When you download this, all you have to do is double click on it, and it'll just give you step-by-step instructions as to how to get started with it. So that's how you install your what do you call it, Java Development Kit. And once you have your Java Development Kit installed, the next thing to do would be to install your integrated development environment, or IDE. Now there are multiple people have got multiple preferences. Some of you might have already used like another IDE which is not listed here, which is NetBeans. But I prefer to use either of the two, which is Spring Tools Suite, which is like an IDE which is based on NetBeans specifically. So it's NetBeans is an open source IDE. So what this Spring Tools Suite does is basically it has taken up that particular IDE, and it has modified it and extended it to be more powerful and more feature rich. And obviously it has better support for Spring framework, so which we are going to do later in the course. So I would highly recommend that you get started with Spring Tools Suite. It's also open source and free for usage, so you can use Spring Tools Suite the same way as you use NetBeans, so you don't have to. And the instruction for installation are like fairly simple. You just download the installer, double click on it, and it does rest for you automatically. You don't have to like do any kind of setup. It's pretty straightforward. But however, if you still face problems, I'll be happy to help you with the installation part. If there is some sort of misconfiguration happen somewhere, we can fix that. Another IDE is IntelliJ IDEA, which is like, there are two variants of IntelliJ IDEA, and different I like this IDE a lot. It's a very good IDE, very powerful, and I guess like it's the best Java IDE available today. There are two variants of this IDE. One is a paid version, other one is a community edition, which is free. There are some features which are restricted on a community edition. So unless like you are a very advanced Java user, you will not be required to use IntelliJ IDEA. But if you think you need IntelliJ IDEA and you want to be more productive, you can buy a license for IntelliJ IDEA, because it doesn't support the web development and those kind of features quite well. For those, you'll either have to go to Eclipse or NetBeans. Okay. So these are the prerequisite tools that you need. Now we'll just analyze on a very high level, like, what is the anatomy of a Java program. So a typical Java program, how does it look like? So if you see here, you have got a class which says public class hello world. We'll discuss about in great detail the meaning of each of these keywords, but just to explain right now, it's a class. So class is like everything that you define, every executable software piece of code comes bundled as a part of a class in object-oriented programming. So if it's not a class, you cannot execute it. It's as simple as that when it comes to your object-oriented programming. So you cannot just execute a function. A function has to be packaged in some sort of a class. So the class is the fundamental building block which can be executed, right? And then a class is a collection of functions. So if you see this public static void main, different people call it different with different names, functions, methods, procedures, but they generally have got like distinctions based on the language that we are talking about, but essentially they all mean the same, some sort of a unit of your code which is executable by itself. It might call other functions in itself, but that is like a name that you have given to a specific role or a specific piece of code that performs a specific role. So here we are talking about this main function. So main function, if you see, it has got a very specific signature. It has got public static void main, which means that it's a static function. We'll talk more about what static is in the object-oriented class. Then void means nothing. So something, this function doesn't return anything. It's a void. So the next keyword is a void, which means that it's the return type of this function. This function doesn't return anything. So it's like it's a function which does something but doesn't return anything back to the caller. So whosoever calls this function will not get anything back, right? And the next thing is its name. Main is the name of the function, so it's the identifier of the function. So it says public static void main, which means that it's a public function. I'll not discuss about static being right now. We'll talk about static later on. Void means is nothing. Like void is, it's the English term which means nothing. So this function returns nothing, and the name of this function is main. Now the next thing that you see is string, and then it's string with square bracket and then args. So this args is the name of the parameter that the function expects you to pass. So if you call this function, it expects that you supply it the value of args. Now this args is an input parameter. So what it means is that you input the value of args inside this function so that it can use those args, it can use the value of args for its execution. And finally, this string with a square bracket means that it's an array of strings. So strings are like the normal strings, like the textual values that we have, and an array is like a concept in computer programming where it's a type of collection. So if you want to store a collection of strings, you will create an array of strings. So that's what this string with a bracket sign means. So having this is the signature of the method, which means that this like we have signatures, we write our initials, right? So this is the signature of the method, and its name is main. Now a main method is a special method in a program in that it can act as an entry point of the program. So what means by being an entry point is that when you create a program, the operating system needs a reference location from where the control can flow into the program. So let's say I'm running Windows, and if I want to run a Java program, that Java program needs to have a main method so that my Windows operating system can pass the control to that main method. So that would be the main the method or the function which would be called first by the operating system, and then the entire flow is now in the control of the main method. So main method decides which other functions to call, what other things to do. So this is the reason we call it the entry point of the program. the below line, if you see, we have this curly braces start and the curly braces end. In like Java language, if you see, the curly braces are the meaning of the curly braces start and end is subjective. It's dependent on the context that we are talking. But generally, what it means is it's like the start of the scope and the end of the scope. So when the curly braces start, it means that the scope is starting, and when the curly braces end, it means that the scope is ending. Now, what do you mean by scope? Scope is like the current context gets defined, or you are defining the limit of the current context. So, for example, here, if you see, the main method starts, the body of the main method starts where the curly braces start, and the body of the main method ends where the first where we have this first closing curly brace. So if I come here, this is the start of the main method body, and this is the end of the main method, and this is like everything in between will be in scope for main method. Anything not in here will be out of scope for main method. So that's what scope means. So the same applies to the class. If you see here, we have this curly brace starting here, curly brace ending here. So this is the scope for the class. So this entire thing from here till here is the scope of the Hello World class. So you can only access what's in scope. You cannot access anything which is not in scope. So if, let's say, if I have another class which is class ABC, and there is another method which is not public, it's like not public method, it might be like ABC, and the name of the function could be XYZ. I cannot access that XYZ function in the Hello World class because it's out of scope for Hello World, so it's not in the scope. So that's one thing. The curly braces are also used to define a block of code. So if you want to like have a clearly defined scope for a specific block of code, you can enclose that block of code in just the curly braces. It is not required to be a function. It is neither required to be a class. Like you can have curly braces start and end after this system.out.println, and then just go beyond that. So that's also allowed, and that's perfectly normal for people to do. This is like the basic anatomy of a Java program. There will be like more advanced topics like interfaces, enumerations, and those kind of things when we'll discuss more about the object-oriented nature of Java. But to start with, this is like the basic like structure of how a Java program is like structured, organized, and what are the building blocks of it, the fundamental building blocks. So if you see here, we have already explained most of it, but you see, when you write the code, you create each class in its own specific file. So for example, this one would be stored in a Hello World file, hello world.java, and the name of the class is also the name of the file that you create. By default, Java enforces this rule, but you can override this rule if you want to, but it's not recommended that you do that. So your Java programs by default will like each class gets stored in its own specific file inside the project. The second thing to be aware of is that when you write a Java program, one complete program, if it's like a real program in the real world, will have multiple files or ultimately the multiple classes. So because that's the principle, or that's the rule of object-oriented programming, in order to make the most out of it, you distribute responsibilities amongst different objects so that you can deal with the smaller parts of the logic at one time, and then write more robust and maintainable software. I have already explained all the intricacies of the main method except for one thing, which was this string A. Now, what does this mean? When this is the command line arguments. So when your operating system will pass control to your Java program, the user might specify some arguments as values to your program. One of the examples that I can think of is, let's say you have a music player, right? A music player written in Java, and when you double click on a file in your computer, a music file, MP3 file, a sound file, when you double click on it, the operating system by default opens a program, right? Default music player that you have. Now, how does your music player know which file to run or which file to play? So what happens is that your program receives that information through command line. So when the operating system calls your main method of the program of the music player, what it will do is basically it will pass the name of the file as a command line argument, so that your program knows which file to open. If the program doesn't receive any input in the what do you call it, arguments, that means that it was just normal start. So you clicked on the icon of the program and it started. But if you double click on a music file and the program starts, that means the operating system passed that command line argument to your program, and that's like a list of strings. So you can pass anything in there. So the operating system generally, like, that's how programs generally open files. They get those command line arguments from your operating system, and you can build any kind of logic around them. So for example, you might write a program that sends out a lot of emails to a lot of people. So what you can do is basically you can pass in an array of email addresses through that string array, or a collection. So as I said, an array is a collection of objects. So a collection of strings would be a string array. So you can pass in a lot of strings or textual values to that program using this string array, and then that program will send out emails to all those addresses which have been passed to it using that command line parameter. So that was all about the introduction and getting started with Java programming. I hope I have been able to provide you a very good overview of what Java is and what to expect in the coming days. And most importantly, I hope that I have been able to get you excited enough to be excited about this opportunity to learn Java and then make a career in this great programming language. I have enjoyed working a lot with Java in my career, although it's not just the Java that I've worked with. So I have worked with .NET, I've worked with Visual Basic, and C, C++, and Python, Scala, a lot of other languages. But that's the requirement of the job. But initially, you have to start with something, and Java is a great language to start with, because it really doesn't allow you to shoot yourself in the foot. So it's a very powerful gun, but it also has safety. So you can be 100% sure that it will be easy to learn, faster than most of the languages, and also going to be really fun to learn Java. The next class we'll talk about in great detail about getting started with Java. So first we'll introduce you the language keywords, like what are the different keywords make up this language. Basically, then we'll talk about the naming rules and conventions for identifiers. So how do you create identifiers? What are identifiers in the first place, and what are the naming rules and the conventions that are followed? We'll talk about data types. We'll talk about the building blocks of a program. So how do you make up a program? What are variables? What are methods? And what are objects? And then we'll just dive deep into your objects and classes. It's a distinction, although it's not just the starting point of object-oriented programming, but we'll just try to lay the foundations for the object-oriented programming course that we have later in the schedule. We'll talk about arithmetic operators. So what are operators, and what are arithmetic operators to be specific? Increment and decrement operators, relational operators, equality operators, logical operators, short circuit operators, ternary operators, assignment operators. So these are like a set of operators. And operators, as the name suggests, are like set of constructs which operate on something. So we'll discuss in great detail what operators are, how do you use operators, and what is the requirement to use operators, and what are the rules for using those operators, or where can you use and where you cannot use a specific operator. Then the next step is, or next topic to discuss about is typecasting. So this is, as we said, like there is a topic called data types here, right? So this is data types. We'll talk more about typecasting. So this is related to data types, how and what it means to typecast something. And then we'll move on with the statements. So statements are like statements in general language, natural language that we have, right? So statements tell or assert or say something, and statements give you what do the program an instruction. So statement in general is like a way of telling program to do something. And then we'll talk about different kind of statements. So one of them is selection statement, another one is iteration statement, and the final one is transfer statement. Just to tell you more about it, like you can have a normal statement, which is like an assignment statement. The other one is your iteration statement, which is a loop, and the transfer statement is your conditionals, which are if else and those kind of conditionals that we use in creating programs. So these are the topics that we are going to cover in the next chapter, and it's going to be really important because this is the fundamental, the basic foundation of your Java knowledge that will be created in this chapter. And the stronger it would be, the better it would be going forward. The easier it would be for you to grasp the more advanced topics and stuff which you might need during your career in the coming days as a programmer. So I'm really excited about this entire thing. And if you think that you have any questions from this session or the next session that we are going to have tomorrow, you can ask them. Let's see, let me just take a look at the time. You can ask them here right now, or maybe you can ask them tomorrow before we begin the class. So whatever, if you think it's okay to ask right now as well, because sometimes it's really helpful to answer the questions right away, because then you get a very good flow of getting the information back and forth. But if you think like you need some more time to think about it, that's also okay. You can ask those questions tomorrow. But for now,
quick question, Pradeep.
Yeah.
So, in the course of practice, if we have any question, like how can we reach out to you, or everything has to be done through this session?
Yeah, basically, that's a very good question. What you can do, I'm sorry, what's your name? I'm really bad with names. I'm really sorry for that.
This is Daniel.
Hi, Daniel. So basically, Daniel, what I would suggest is like, it depends. If it's like a very detailed question wherein like you need a very great explanation, it would be already it would be very advisable that you drop out an email to training.janbask, right? So you must have received an email from training, right?
Yes.
Yeah, you can just send out an email there, route your email to me, and then basically I can just go ahead and respond back to you. If it's like a very detailed topic wherein like it's a big deal. If it's not, then maybe yeah, that's it's really advisable that you just do that through this because whatever question you have might be a question that somebody else might have. So just if you ask that question, it will benefit everybody else as well. And like because this is a collaborative learning session, your questions will help others also to like be updated. And sometimes it might be the case that you have a question, you have come up with a question, but nobody else came up with that question, but they still don't know about it. So that's another area wherein like you will be able to help your friends joining the video.
Okay. Thank you.
Yeah. Okay. All right. So anyone wants to ask anything about the things that we have discussed so far? Basically, if you think anything that needs clarification, or if you have any questions about anything, you can ask me.
Good.
Okay, Susan, do you want to ask anything? Susan, can you hear me? I'll then move ahead with Siddiqui. Siddiqui, do you have any questions?
No, I'm good. Thank you. I will ask you tomorrow.
Great. You already had a discussion with Daniel. Daniel, do you have any further questions that you would like to clarify?
No. Thank you.
Welcome. So, guys, I guess that's it for today. Then I'll see you in the class tomorrow. And the idea is like if you think that you can maybe get your system set up before the class, like with all the IDs and the Java runtime environment and the JDK, it would be great. If you face any problems during the installation, or if like you set it up but it's not working, basically I'll be more than happy to help you in the class tomorrow. But like tomorrow we'll get started with the actual practical assignments and things that writing programs and understanding them. So it's really important that you get your system set up before that, so that we don't lose any time and are in a position to get started quickly.
Pradeep, sorry to interrupt. What was the IDE that you recommended?
As I said, like I personally like using Spring Tool Suite. It's
Okay.
STS. Yeah, you can in the presentation, if you see there is a link to download that IDE.
Okay.
Here, on which slide do we have that? Yeah. So you're able to see my screen, right?
Yes.
And this is the link. Like you can use Spring Tools Suite. This is
Okay.
the very IDE. It's based on Eclipse.
No, thank you. See you tomorrow.
I'm sorry?
I think she's dropping off.
Okay.
The bottom link you're talking about, right? Right, all the way down there, where you add.
Yeah. So there are like two links there. One is
Right.
for Spring Tool Suite, this one,
Right.
and the other one is for IntelliJ IDEA. You can use either of them, but I would highly recommend that you use Spring Tool Suite, because that you don't have to install anything else later on in the course. So if you get started with this.
Okay, got it.
Sure.
Thank you.
All right. Thank you.
Welcome. All right, then I'll sign off for the day, and I'll see you guys tomorrow. Hope you have a great day.
You too. Sure.
You too. Thank you. Good night.
Okay. Good night.